Welcome back. I got too excited and I went like 20 seconds over time. I hope YouTube still lets me publish this video. I'll try my best. But what I was saying is how related these two formulas are, and that makes sense because at this point the ball is stationary and it's completely the same as a ball just being dropped. A stationary ball being dropped from height h. So we can use this formula to do the same thing that we did intuitively, in the last video. So if we're just dropping a ball, the initial velocity is 0, so this term goes to 0. So this term is the only one that matters. And once again, if we're dropping it, we start at height h and we go to 0. So the change in distance is now minus h. And now at squared over 2. Well, that equals gravity times, what's the time? The time is not this full t naught. It's t naught over 2, right? So g t naught over 2 squared over 2. You multiply both sides times -1, and you get this exact same thing. So that's pretty cool. What I love about physics is that there's so many ways to approach problems. You can actually start off with any one of the formulas that we've been looking at, and as long as you kind of keep playing with it, you keep thinking about it, you might not find the fastest route to the solution, but as long as you don't do anything incorrect, you will get the solution. So hopefully this gives you a little bit of an intuition of projectile motion. In the next set of videos, we're going to make it slightly more complicated, but also slightly more realistic. And I'm going to introduce you to what happens in two-dimensional motion. So when you're not throwing something straight up, you actually throw something at an angle, like you normally do. I'll see you in the next video.